Hey everybody! In this video we're going to go over some accuracy and precision sample calculations. If you remember from our previous video or from my notes, percent error is a measure of accuracy and percent deviation is a measure of precision. Your percent error takes your average value or a single value from one trial, subtracts the accepted value which has to be given to you, divide by the accepted value, take the absolute value and multiply by 100. Percent deviation is a single trial minus the average of all of your trials times 100, divided by the average times 100. So we're going to collect some sample data. We have a balance here that measures mass. Mass is measured in grams, which you can see here. We're going to measure the mass of 3 different expo markers. So our first trial is going to be the red marker. As you can see, the mass of the red marker is 8.96 grams. So we're going to record that in our data table. We know that this mass, remember significant figures, this scale gives us 3 significant figures. We know that the mass of this marker actually goes out many more decimal places because the mass of the atoms that make up the marker are so tiny. But this scale isn't precise enough, or it's not good enough to give us those measurements, so we take 3 significant figures. We are absolutely sure that this marker is 8.96 grams. Trial 2 is going to be the yellow marker, and the mass of our yellow marker is being reported as 8.89 grams. Again, we get 3 significant figures because that's what our instrument tells us. The mass of our third marker, our green marker, is going to be reported as 8.74 grams. So we've collected our data. Now we're going to take the average of all of our trials. An average, you'll remember from math, is the sum of all 3 trials divided by the number of trials. So we're going to add 8.96 plus 8.89 plus 8.74, and then we're going to divide by 3. This gives us an average of 8.86333333. But because of our significant figures, we can only report 3 because we were adding and then dividing. We can only report as many significant figures as we have in our original measurements. So we're going to report 8.86 grams, 3 significant figures for our math answer. Now we want to calculate our percent deviation for each trial. Percent deviation tells us how precise our numbers were. So trial 1, percent deviation is going to be the trial 1 data, 8.96, minus the average, 8.86, divide by the average, 8.86, times 100. We put that in our calculator. .96 minus 8.86 divided by 8.86 times 100. We get 1.1, and we want 3 significant figures. So 28 is going to round up to 1.13% deviation for trial 1. We're going to do the same thing for trial 2. We're going to figure out how much, remember as well, a number near 0 is better. So 1.13 is pretty close to 0. That means that this number is pretty well grouped around the average. Percent deviation for trial 2, is going to be the data for trial 2, 8.89, minus the average, 8.86, divided by your average, times 100. We plug that into our calculator. 8.89 minus 8.86 divided by 8.86 times 100. Our percent deviation for this number is 0.3386. So we're going to say 0.33, and then that third digit, because we want 3 significant figures in our answer, is going to become 339% deviation. So this trial is even more precise than trial 1. Let's do the same thing for trial 3. Your percent deviation is going to be the data from trial 3, 8.74, minus your average, 8.86, divided by your average, 8.86, times 100. Plug this into your calculator. 8.74 minus 8.86 divided by 8.86 times 100. You'll notice this percent deviation is negative 1.35%. Percent deviation, if you look in our equation, is not an absolute value. That means you are allowed to have negative numbers. A negative number for percent deviation means that this trial was below average. So a negative number for percent deviation tells us that this particular trial was below average. The last calculation we want to do is the percent error, which tells us the accuracy of our measurement. In order to do percent error, you have to have an accepted value. The accepted value would be given by the instructor, or you could look it up online. So if your accepted value for an expo marker was 8.90 grams. Okay, let's say I looked that up online and I found the accepted value. All of these markers are supposed to weigh 8.90 grams. So I'm going to use the accepted to calculate my error in my data. To calculate percent error, I'm going to take the absolute value of your average. In this case, our average was 8.86. Minus the accepted value, which we said was 8.90, divided by the accepted value, 8.90, times 100. 8.86 minus 8.90 divided by 8.90 times 100. Because it's an absolute value, we can ignore that negative, and our percent error is 0.449. We still want 3 significant figures. 0.449%. Because it's an absolute value, we're going to get rid of the negative. For accuracy, 0 is better. We have an accuracy of 0.449%. We were pretty accurate with our measurements. You could also measure the accuracy of an individual trial by taking, instead of using the average here like we did, you could take the data for an individual trial and compare that to the accepted value. So we could find the accuracy in trial 1 as well. We could do the accuracy for trial 1, 2, or 3. I'm just going to show you trial 1 just so that we do the calculation again. So your percent error is going to be your data now from trial 1, absolute value, your data from trial 1, which was 8.96, minus your accepted value, 8.90, divided by 8.90, times 100. Plug that into our calculator. 8.96 minus 8.90 divided by 8.90 times 100. So trial 1 had an error of 0.674, 3 significant figures, %. So our average was more accurate than just taking one trial. This is often the case. This is usually why we do multiple trials, because taking an average is usually more accurate than a single measurement.